Okay, so in one of the videos, I talked about units. So I talked about units like mass, length, time, moles, and then I mentioned that there are other things that we can use these different units, combine them in different ways to get other variables, as it were, other things that will mean different things. So one example we can say is, what is force? Force is mass times acceleration. Ignore my spelling, as it were. And acceleration is rate or derivative of speed. That is, rate of change of speed is acceleration. And of course, speed is length divided by time. So essentially, force is nothing new except some combination of mass, length, and time, and so forth. Right? So we need to really understand, and one of the things that sort of sometimes can be complicating and a little bit difficult to understand is even mass. You can report mass as grams or kilograms or pounds or different units. So you need to know how to convert between them. Between grams and kilograms is simple. It's 1,000 grams is 1 kilogram and so forth. And then you can use powers of 10 and things like that. Same thing with length. Length can be centimeters, feet, kilometers, distance traveled by light in a year, so on and so forth. But so you need to be comfortable navigating variables that are reported in different units. That's very good. That's going to be very important. You need to understand that. And you will occasionally see volume, which is length times length times length, in gallons, for example. So what is the relationship between gallons and liters? What is 1 liter? And so forth. So the engineer, really be really comfortable traversing between different units. And be careful. If you want to convert from one unit system to another, you need to be very careful that you apply the right type of conversions. Right? Okay, so one of the things I was going to point out is, in addition to the issue with the units, different types of units and so forth, anytime you write an equation in engineering, anywhere, you need to make sure that equation is dimensionally correct or dimensionally consistent. So if I'm going to write an equation like a plus b equal to c, we need to make sure that they all have the same type of dimensions. By that I mean, if a is speed and b is speed, and of course c will be speed and they are velocity, if you will, they have the same units. But if a is speed and b is distance, you can't add them, because this has units of length divided by time, this has units of length. And so when you're writing an equation, not only the equation should make sense, but they should be dimensionally consistent. They should be right. So they should all have the same units. This is also very important. And this is also when you convert between one to another. And this is, as we get more complicated equations, sometimes converting between one unit system to another can be confusing. Very often when you're reading literature, reading Wikipedia, whatever, people report things in different units. So one of the things that you need to become really comfortable with is, appreciate, how do you go from feet to centimeters? How do you go from pounds to kilograms? Or how do you go from volumes of, say, ounce, if you will, or to volumes of liters or gallons, and so on and so forth. Now, you don't need to remember them, if you will, all the conversions, but you need to, if you see a table, how do you use those tables and do the conversion? So it's going to be important, and this is going to come again and again as we go through this class.